Jai Shri Ram guys. Today we see about heap data structure. What is heap data structure? Its types, operations, add, remove, peak. One example of each type. Basically two types. We see example of both types. Uh, like in our previous Q video, we see operations through example. In this video also we see operations and understand operations through examples only. We do not see implementation in this video. We only see what types operations example and its some applications. Let's start. So basically heap data structure is a special tree based data structure. It is a complete binary tree in which our this is like complete binary tree where complete binary tree is filled from left to right. Like it is filled from left, then if new elements comes, first this field, then added here, then added here, then added here from left to right, then added here, then added here, then added here. If one more element come, then it adds here. So this is complete binary tree. Heap is implemented by array but visualize as complete binary tree. So it is a complete, we can say, heap is a complete binary special tree based data structure which is a complete binary tree. So heap is visualized by complete binary tree, but internally it is implemented by arrays only. So let's see, we have mainly two types of heaps. First is min heap and second is max heap. So let's understand each type of heap one by one using examples and also see operations. As we see, operations are add means add in a heap, either min heap or max heap. Remove from heap, either min heap or max heap. Peak of a heap. So the time complexity of add, first of all we see what is min heap, then we discuss time complexity of insertion, removal and deletion. Sorry, insertion, removal and peak. So let's see, we consider this max heap and this set of elements. If we add 1, then 1 is added into heap. Now what you get at peak? You get 1 at peak. If you remove, you get 1 and 1 is removed from the heap. So this is 1. So if we add 2 now, then max heap. So max heap meaning you have only access of top element like stack, either you pick or remove. But max heap property is that you always get maximum of all elements which are present in a heap. So here 1 and 2 you get 2 at the top because 2 is maximum from both 1 and 2. So this is, you if you remove from heap, 2 is removed. If you get peak, you get 2. If you add 3 now, you will get 3 because 3 is the maximum from. If you add say 0, you say add 0 in a heap, then now what you get? Yes, your answer is right. You get 3 because 3 is maximum, and if you remove, 3 is removed. So this is max heap. Now we see min heap. Min heap is also same as we see in max heap. We get always maximum element at top, but in min heap it is opposite. You always get max minimum element at top. If you add 1, now you get 1 at peak and 1 at 1. If you remove from heap, 1 is removed. Now if I add 2, then 2 1 is now difference is minimum at the top. So here you get minimum at the peak, which is 1. So if you remove 1 is removed from the heap. Now if I add 0, say if I add 0 here, then 0 is added into heap, and now you get 0 because 0 is minimum. If you remove, 0 is removed and 1 2 are remaining. So this is min heap and this is max heap. So we see example, types, operations. So now see what are the applications, why we study min heap and max heap. Basically why we study heap. So the applications of heap are priority queue. We where priority queue is abstract data type which defines what functionality we want to achieve, and it is implemented by heap. So heap sort. So heap is used in heap sort algorithm where its time complexity is n log n. K largest, K smallest type of questions we use heap to optimize the solution. Time complexity. Solutions time complexity. Basically, we use heap to optimize the time complexity of our solution. We use heap in our graph algorithms. When you study graph, you see that you use heap, min heap or max heap in your algorithms like digest algorithm, shortest path algorithm, which is so shortest path algorithm. So one thing we don't see is that what is the time complexity of add. So the time complexity of add is big O of log n. The time complexity of remove is also big O of log n, where n is the number of elements present in a heap, and peak time complexity is big O of 1, big O of 1 time complexity peak. So big of log n, big of log n, and big O of 1 time complexity. So this is all about heap data structure.